The Alhambra Palace in Granada, Spain, a pinnacle of medieval Islamic art and architecture, built by the Nasrid dynasty, is renowned for its intricate artistry and ingenious water management system. This system, a marvel of Nasrid engineering, features a seemingly impossible ability to make water flow uphill, showcasing the advanced hydraulic understanding of its creators. The Alhambra's enduring water system, still functional centuries later, powered stunning fountains, lush gardens, thermal baths, and even timekeeping devices, proving that water was not just a resource, but an artistic, cultural, and engineering marvel, deeply woven into the fabric of the palace itself. The Alhambra's history began in the 9th century, with evidence of Roman and Visigothic presence, and later a fortress was built. Its transformation into a palace started with the Nasrid dynasty in 1232, when Muhammad I began construction. The Alhambra's development continued for centuries under Nasrid rulers, with the 14th century being a golden age. The water system's perfection even took 3 generations. In 1492, the Christian Reconquista led to the Alhambra becoming a Spanish royal residence. Later, it faced disrepair and then restoration. Its hilltop location was strategic for defense, but supplying water was challenging, leading to its renowned hydraulic engineering. The architectural design of the Alhambra reflects its dual nature as a fortress and a palatine city. Its layout is characterized by a series of interconnected courtyards, gardens, and buildings, each meticulously designed and integrated with the natural landscape. Key areas include the formidable Al-Kazaba, the private Nasrid palaces such as the Mexuar, the opulent Comares Palace, and the celebrated Palace of the Lions. Beyond the main palace complex lies the Generalife, conceived as a serene summer retreat with exquisitely designed gardens. Courtyards like the Court of the Lions and the Court of the Myrtles serve as central organizing spaces, with water playing a pivotal role in their design, contributing to both their visual appeal and the overall ambience of tranquility. The Generalife Gardens further exemplify this integration, featuring elaborate water channels, cascading fountains, and lush vegetation, evoking the Islamic ideal of paradise. Water features, including serene pools, intricately carved fountains, and gently flowing channels, are seamlessly interwoven into the architectural spaces throughout the Alhambra. This deliberate integration blurs the distinction between interior and exterior realms, with water acting as a unifying thread that connects courtyards, gardens, and indoor areas in a harmonious flow. Beyond their aesthetic contribution, the strategic placement of these water features served a crucial practical function: to cool the palace environment in the intensely hot Granadan summers through the natural process of evaporation. The Alhambra's elevated position presented a challenge for its builders, which Nasrid engineers solved by diverting water from the Darro River 6 kilometers upstream, where the elevation was higher than the palace. This was achieved through the Royal Canal, which navigated challenging terrain using tunnels and aqueducts, while maintaining a shallow slope to ensure a constant gravitational flow of water towards the Alhambra. To generate water pressure for the palace's fountains and systems, the engineers constructed a large storage pool at an even higher elevation than the Alhambra itself. Water from the Royal Canal flowed into an underground pipe and collected in a well. A water wheel, powered by animals, lifted the water to the surface to fill the storage pool, which could hold around 400 cubic meters of water. This elevated reservoir pressurized the entire water system and provided a backup water supply. From the storage pool, water was distributed throughout the palace via a network of channels, supplying the pools, fountains, baths, and gardens. The entire system was a testament to the medieval engineers' understanding of gravity and fluid dynamics. The Alhambra's hydraulic system had the remarkable ability to raise water 6 meters to the soldiers' quarters, which were at a slightly higher elevation. This was achieved using a device that didn't need external power. Water flowed into a container with a hole at the bottom, leading to another container below. As the water flowed down, it created a whirlpool in the top container, forming a low-pressure area that sucked air into the lower container. The air and water mixed, creating a less dense mixture that was forced into a thin pipe. This lighter aerated water could then travel to a higher elevation. This method used the density difference between aerated and pure water. Creating a whirlpool to introduce air showed advanced understanding of fluid mechanics. This device was likely less efficient than the main gravity-fed system, as it was only used for a small lift in a localized area. The precise mechanism is still debated by scholars, suggesting its complexity and ingenuity. Water was not only a vital resource for the inhabitants of the Alhambra, but also a central element of its artistic and architectural expression. The palace boasted numerous fountains, each a testament to Nasrid artistry and engineering. The most iconic is undoubtedly the Fountain of the Lions, located in the heart of the Palace of the Lions. This magnificent fountain features a large dodecagonal basin resting on the backs of 12 intricately carved marble lions, from whose mouths water flows into the surrounding channels. Other notable fountains include the serene Fuente de los Arayanes in the Court of the Myrtles, whose elongated pool reflects the surrounding architecture with captivating beauty, and the Lindaraja Fountain, a 14th century marble cup installed in the Garden of Lindaraja. An extensive network of water channels, ranging from narrow rills to wider canals, meandered through the Alhambra's courtyards and gardens. These channels served the practical purpose of irrigating the lush vegetation, while also contributing significantly to the aesthetic appeal and the soothing auditory experience of the palace with the gentle murmur of flowing water. Unique water features, such as the water stairs, Escalera del Agua, in the General Life Gardens, further showcased the creative integration of water into the palace's design. Beyond the fountains and channels, the Alhambra's hydraulic system powered the palace's thermal baths, or hammams. The heating of these baths was achieved by water flowing into an underground control room and passing through a copper boiler heated by burning wood. This boiler provided hot water for the baths and steam for underfloor heating in the hot rooms and steam rooms. Legend also suggests that the Fountain of the Lions functioned as a water clock, with water flowing from a different lion's mouth each hour. This mechanism likely involved a system of holes and internal pipes within the fountain's central bowl, regulating the flow of water to each lion. A siphon mechanism within the bowl would have allowed for automatic draining and resetting after a 12-hour cycle. The Alhambra's innovative hydraulic system used gravity, water wheels, and a whirlpool mechanism to manage water for functional and aesthetic purposes. Its sophisticated design, which integrated water into the architecture, and advanced engineering distinguish it from other medieval systems and continue to inspire modern engineers. Water from the Darro River was diverted to the Alhambra Palace via the Royal Canal and a water wheel. From an elevated storage pool, pressurized water flowed through pipes to palace features, including the Fountain of the Lions with its sequential lion activation and a two-container system, using a whirlpool to push water uphill to the soldiers' quarters. Modern interpretations and reconstructions visualize these complex mechanisms, likely constructed with copper, earthenware, and potentially cast iron pipes.